Watch the complete playlist on the app Pions. Download the app now.
So let's start our question number 1. Here it says calculate the electric field strength required to just support a water drop of mass. So let me write as usual what is given. So mass here is given as 10 to the power minus 3 kgs. This is our mass here, mass of liquid drop, and having a charge. Be very careful. This is Q. Q is nothing but 1.6 into 10 to the power minus 19 coulomb. Okay, this is the charge on the water drop and this is the mass. What you have to do, the question is saying calculate the electric field strength required to just support a water drop of mass this and charge this. So first of all, if this has this much mass, then force F will be equals to what? Weight of the object or weight of this drop here. So if this is a drop, it is falling down, right? It is falling down because of what? Because of gravity, right? So weight of this object, so weight of this drop, so this must be equals to this force. Now if it is balancing, okay, what is balancing? The electric field. The electric field should be in opposite direction first thing, and it should overcome this weight. So if to overcome this weight, this force must be equals to QE. Force F equals to QE, we know this expression, so that will be equals to mg. So electric field E will be equals to mg upon q. Now what is the mass here? 10 to the power minus 3. Acceleration due to gravity, let's assume it as 10, okay, just to make it simple, whole divided by q, which is 1.6 into 10 raised to minus 19. Now 1.6 into 10 raised to minus 19, okay, when you take it, okay, on the top it will be 6 into 10 raised to 18, nearly 6.25 you can make it, but it's approximately 6 into 10 raised to 18 into 10 to the power minus 3 into 10. 10 to the power minus 3 and this power 1 minus 2 and here it will be nearly 6 into 10 raised to 16. And what's the unit of electric field? Newton per coulomb, okay, because we know that force F equals to QE. E will be force per unit charge, so Newton per coulomb, that's the unit of electric field. This was our first question. Let's move to question number 2. The question number 2 says an electron moves a distance of 6 centimeter. So let me just write here, okay, distance S is equals to 6 centimeter. I am rewriting here, directly converting here into meters. Why? So that later I don't forget it. So initially when you are writing, write it in meters only. When accelerated from rest means initial velocity is 0, by an electric field strength here E is 2 into 10 to the power minus 4. It's in standard units, Newton per coulomb. Okay. Calculate the time of travel. T you have to find. The mass and the charge of electrons are m equals to 9 into 10 to the power minus 31. Okay. And charge of electron is 1.6 into 10 raised to minus 19. Okay. So this is kgs and this is coulombs. Okay. Let me repeat the whole question again. An electron is moving this much distance from rest due to the presence of electric field. Let's go into the core concept of this. Now, why the electron is moving? Because of the electric field. And why it is moving because of electric field? Because it is experiencing a force. And what's the force? Force will be equals to QE. Just now we have seen in the previous question also. So F equals to QE. F is nothing but mass times acceleration, and that will be equals to QE. And acceleration is nothing but QE by m. Let me repeat again. This is the acceleration produced in the electron. Great. If this is the acceleration and it is traveling this distance, s equal to this, then from equations of motion class 11th, s equals to ut plus half at square. Correct. Now u is nothing but 0. As per the question, the electron starts from rest. So u is 0. So s will be equals to half at square. Now you can take everything on the other side. So 2s upon a, that will be equals to t square. Or you can say t will be equals to root under 2 times distance upon acceleration. Right? And what's acceleration? QE by m. So QE by m goes up. So when we put here t equals root under, let's put the values, 2 into s is 6 into 10 raised to minus 2, m Mass is 9 into 10 to the power minus 31 whole divided by Q 1.6 into 10 raised to minus 19 and electric field which is 2 into 10 to the power minus 4. This will be equals to root under, let's cancel this 2 with 2, 1 upon 1.6, 6 into 10 raised to 18 whole into 6 into 10 raised to minus 2, 9 into 10 raised to minus 31 and whole divided by 10 to the power minus 4 also I am writing on the top. So it becomes 10 to the power plus 4. Nothing left now? Yes. So this 6 and the 6, 1 6 will come out. 9, 3 will come out. And let's see what we left with the powers. 18 minus is 2, 10 to the power 16 into 10 to the power minus 31 and 10 to the power 4. 16 and 4, 20, 20 and minus 31, minus 11. So this will be, T will be equals to 18 into root under 10 to the power minus 11. And 10 to the power minus 11, okay? 10 to the power minus 11, not T to the power minus 11, 10 to the power minus 11. This can be written as T equals to 18 root under 10 to the power minus 1 into 10 to the power minus 10, correct? And 10 to the power minus 10 can be written here as how much? 18 into 10 to the power minus how much? 5. And what about, sir, this root under 10 to the power minus 1? That will be 1 upon root 10. So upon root 10. Now you can rationalize further if you want, and you can write the answer like that. So answer is 18 upon root 10 into 10 to the power minus 5 seconds. Let's move to our next one. Question number 3. It says 2-point charges plus 5 into 10 to the power minus 19 coulomb and plus 20 into 10 raised to minus 19 coulomb, both are positive charges, are separated by a distance of 2 meter. Great. Find the point on the line joining them at which electric field intensity is 0. Electric field is 0. Very common type of question asked in boards. So focus here. I am placing here our first charge. First thing is to draw the diagram. Very important. 5 into 10 raised to minus 19 coulomb. Another one is 20 into 10 raised to minus 19 coulomb. Correct? And here it will be the line joining the two charges. Let's call it as A and let's call it as B. This AB is 2 meters away, right? 2 meter is the gap between A and B. Okay. Now, at this point, you have to find a point where the field is 0. I don't know where it must be. So let's assume that this point is point P, at which the electric field is 0, cancelling each other. Sir, why it is cancelling at P only? Why can't we cancel it here or here? We will see that within a minute. Okay, because these points, point C and point D is also along the line joining the two charges only. If you draw the line, it will be along the line only. So why at P you are taking? So see here, if this is positive, the electric field due to a positive charge, radially outward or inward? Think about it. Electric field due to a positive charge is radially outward or inward, away from the charge or towards the charge, away from the charge. That is our convention. Now at this point, C, due to the charge at A, it is outward. Now electric field due to B, again outward, away from the charge. Both away are adding up. Both are pointing in the same direction, so it can't be 0. Here, due to B, outward. Due to A, also away from the charge, outward. So again, they are adding, they can't be 0 over there. At point P, electric field due to A, sir, outward, away from the charge. Due to charge at B, outward, away from the charge. This is electric field at point P due to A. So EPA, let's call it. Electric field due to B at point P, EPB. I hope this is clear. Now, let's write the magnitudes. Okay, both are pointing in opposite direction. So theta is 180, and if theta is 180, we know that electric field will be subtracted. So net electric field at point P will be equals to EPA minus EPB, correct? Electric field at point P due to A minus electric field at point P due to B. Now, what is electric field at point P as per the question? 0. As you can see here, it is 0. If it is 0, let's put it 0 here. What is EPA? We will write it. We will find it within a minute. Minus EPB. Let's take EPB on the left hand side. So, EPB must be equal to EPA. Even if you start your derivation of this problem here, that is also fine. Logically, if something is cancelling out, if two vectors are cancelling out, then that the only thing that can happen is maybe they both are in opposite direction and same in magnitude. If they are in same in magnitude and opposite in direction, then only they will cancel, no other option. So EPB and EPA we will put here. So first of all, let me remind you, the electric field formula is 1 by 4 pi epsilon naught Q upon R square. 1 by 4 pi epsilon naught is nothing but K. Q is the charge whose electric field you are finding, and R is the position of that point from the charge where you are finding the field. So this is our general formula. Let's put here 1 by 4 pi epsilon naught. What is our first charge? Sir, first charge is 5, PB we are finding. So electric field at P due to B is charge is 20 into 10 to the power minus 19. Sir, but we don't know what is the location of PB. So let's assume from first charge, the location of point P is X meters. If this is at X, what will be the position here? 2 minus X, obvious it is. Because the total length is 2 meters, that is X. Then this has to be 2 minus X. So this will be our 2 minus X whole square. Be very careful, it's a square. Equals to K, which is 1 by 4 pi epsilon naught Q. Q is how much here? 5 into 10 raised to minus 19 whole divided by the separation, which is X square. I hope this is clear. Now 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught straight away cancels. If you have such confusions how it got cancelled, take 4 pi epsilon naught on the left hand side. It will go in the numerator, then you can cancel out. 10 to the power minus 19 and 10 to the power minus 19 gets cancelled. Correct? Okay. Then what we will do next? Our next task is 20 upon 5. I am cross multiplying. 20 upon 5 equals to 2 minus x whole square whole divided by x square. In case if you have not understood, I took this 2 minus x whole square, this part on the right hand side. It will go in the numerator over here. And I took this 5 on the left hand side, it will go in the denominator because that was in the numerator on the right hand side, right? Now, very common thing which students do, though you can do that, okay? But another simple method is, I am not opening this bracket, I am not removing the square. Majority of people, they remove the square, make it quadratic equation, find the solution, fine. But if you are a bio student and you don't know how to find quadratic thing at this stage, then it can be a problematic thing. So we will solve it without using quadratic. Okay. So 20 upon 5, that will be our 4 equals to, I'm just writing this whole thing as 2 minus x upon x whole square. Now let's take root on both the sides. Taking here root, it will be 2, which will be equal to 2 minus x upon x. And even when you take the root on the left hand side of 4, you will get another result also. So let's make a space here and write it as minus 2, because minus 2 square is also 4 and plus 2 square is also 4. So when you find the root of 4, you will get plus 2 also and minus 2 also. Correct? So let's get two values of our x. So this will be 2x equals to 2 minus x. Taking x on the left hand side, it will become 3x because 2x plus x will be 3x equal to 2. Our answer is x equal to 2 by 3. So distance of that point where the electric field is 0 from charge A is 2 by 3. What about our second solution? Let's see if it is consistent or not. So minus 2x equal to 2 minus x. Minus, when you take this x on the left hand side, it will become plus and you will get minus 2 plus x, which is minus x equal to 2, and x equal to minus 2, which gives you inconsistent result. So our correct answer for this particular problem is x equal to 2 by 3. So that is our positive result. The point P should be at a distance of 2 by 3 from the first charge. So our next question is here. 2-point charges plus 6q and minus 8q are placed at the vertices of B and C of an equilateral triangle. So this is an equilateral triangle ABC with side A as shown in the figure. Okay, so very simple. There is a 6 coulomb q charge, sorry, and here minus 8q. And the side length of this equilateral triangle is A. Obtain the expression for the magnitude and the direction of resultant field. Now, this is very, very important thing. Four things which you have to be very careful while reading the question. Force, field, potential, and potential energy. All four things are different. And since they are different, okay, their formulas look quite similar. Okay, so you have to be very careful with that. So direction of resultant electric field at vertex A due to these charges. Direction also and magnitude also. So let's proceed in a similar fashion. We have a positive charge here as per the question at B. If there is a positive charge, okay, what is this length? A. This length A, because it's an equilateral triangle. So if it is a positive charge at point A, the field will be radially inward or outward? It will be outward, because for a positive charge, it will be away from the charge. Along this direction, this will be electric field at A due to B. Correct? Sir, why you have drawn it at this direction? Why can't you draw it like this or there? Why? Because what is the condition to draw the direction? It should be along the line joining the point at which you are finding and the charge where it is placed. That line, along that line you have to draw. Clear? Sir, what if this charge was placed here and they are asking at point A? Will it be still in the same direction? No. Then you will imaginary line like this. This side it will be. Okay, along the line joining the charge and the point. Great. Electric field at A due to C will be radially outward or inward? Sir, it will be inward towards the negative charge. Radially inward towards the negative charge. So it will be EAC. Electric field at A, okay, due to C towards the charge. Why towards the charge? Negative charge. Clear? Okay, great. So one is vector in that direction, another vector is in this direction. What is the angle between them? So we know equilateral triangle, each angle is 60 degrees. So if this is 60, this becomes a linear pair and 180 minus 60, which is 120 degree. This is the angle between the EAB and EAC. Okay, great. So if EAB and EAC has this angle, how will you find the resultant? We will see within a minute. Let's first find the magnitude of individual electric fields. So electric field EAB, that will be equals to, I'm just writing it as K. You can write 1 by 4 pi epsilon naught. I'm writing it K to make the calculations simple. So this will be K. Charge is 6Q upon separation is A square. I hope this is clear. Separation of AB. Okay. So you can write it as KQ by AB square. AB is nothing but A. This is our electric field EAB. Let's write electric field at point A due to C. That will be again K 8Q upon separation A square. If you are still confused, sir, why you have not taken the negative sign here? Listen very carefully. Since it is negative, the direction of arrow is downward. Clear? If it was positive, this EAC was supposed to be in the opposite direction away here. So you have already considered the negative sign in this arrow. You can't do it twice. Let me repeat again. Since here at point C, the charge is negative. And since it is negative, the arrow of EAC is towards the negative charge. If it was positive, it was supposed to be away. So these arrows are already considering the signs. So you will not repeat the sign again. So that's why EAC, we have not taken here negative sign. So you have to avoid signs in which cases? Fields and forces. Be very careful with that. Done with that? Great. Now what we will do? We will simply directly add them? No. You can't add any two vectors like that. Let me remind you a relation from 11th standard. If you are given with any two vectors, R will be equals to A square plus B square plus 2AB cos of angle theta, where A and B are the two vectors which you are adding. Theta is the angle between them. So what is here theta? In our problem, theta we got 120 degrees. Sir, which angle we have to consider? The angle between the two vectors. The angle between the two vectors we have to take. That is our 120 degree. Now this will be equals to root under A. What is A? A is K into 6Q upon A square whole square, first vector, plus B vector, which is K 8Q upon A square whole square, A square plus B square, plus 2 times A. A is what? K into 6Q upon A square into B, K into 8Q upon A square cos of 120. I hope now you should know that why I have taken that 1 by 4 pi epsilon naught K. You can take it as 1 by 4 pi epsilon naught, but it will look more complicated for you. So to avoid that, I just took it as K. Now what is cos 20? Bio people, be very careful. You have to remember these values. Cos 120 minus half. Let's substitute here. So cos 120, I am putting here minus half. And when you put minus half, this 2 will cancel out with this 2, and the minus 1 will take place over here, this plus. So let's see what we are getting here. Be very careful with the calculations. So this will be over here root under K square 36 Q square A to the power 4. K square 64 Q square A to the power 4. Minus, be very careful from where I got minus, this minus half. 2 cancels minus. K into K, sir, K square. 6 into 8, 48. Q into Q, Q square A to the power 4. All the three terms have something common in them. Sir, what is common in them? Let's write that. K square is there in all the three terms. Q square is there in all the three terms. E to the power 4 is there in all of them. So what we left with is the first term 36. Second one 64. Third one 48. Clear it is? Let me repeat. In case if you have not understood how to take common, simply multiply this outside bracket inside this. So 36 into K square Q square by E to the power 4. 64 into this thing and minus 48. 36 and 64, 6 4 10, 1 6 4 10, 100. 100 minus 48 we left with. So this will give us the resultant electric field at point A will be equals to, be very careful, what can you take this K square Q square and A to the power 4 out of root? Yes, you will be left with 1K 1Q because root and square will cancel, and A to the power 4 you left with A square. Root under 100, 36 plus 64, 100 minus 48. And 100 minus 48 is how much? Let's see. So this will give us net electric field at A will be K Q upon A square. 10 minus 8 is 2 and 9 minus 4, 552. So root 52 KQ square by A square. That's your final answer for this question. Let's move to our next question. Great. Our next question says two charges, one plus 5 microcoulomb and another one minus 5 microcoulomb are placed 1 millimeter apart. Calculate the dipole moment. Direct question, very simple question. You are given with first charge here. I am writing here 5 microcoulomb. Another one here minus 5 microcoulomb. Both are separated by a distance of 1 millimeter. Correct? Calculate the dipole moment. So dipole moment P is equals to 2AQ. Direct question, sir. Why you are doing such a simple question? Because this is the question where 90% people go wrong. Why they go wrong? Because they simply read the concepts. They don't solve problems. And they remember the formula. Even after remembering the formula, they do it wrong. Why? Because in the formula, when we solve it, when we derive expressions, in the class we assume this whole distance between the positive and negative charge as 2A. The whole distance is 2A. And what students do in exams? They multiply this separation and write it as 2 into 1 into 1 millimeter, whatever, into charge. This is completely wrong. This is completely wrong. Be very careful with this. The whole gap, 1 millimeter itself, is 2a. It's not a. So don't do that mistake. Very common mistake students do this. So the separation between the first and the second charge is 1 millimeter. So 2a itself is 1 millimeter. So 1 into 10 to the power minus 3. And charge q, what is the charge q? The charge q is 5 microcoulombs. So 5 into 10 to the power minus 6. No need of taking negative. Clear? Let me repeat again. 2a itself is 1 millimeter. So I converted millimeter into meters. And the charge is 5 into 10 to the power minus 6. So this gives us 5 into 10 to the power minus 9. And what's the unit? Unit of this is meters, and that is coulombs. So coulomb meter, not centimeter. Coulomb meter it is. Be very careful. This is our complete answer to this question. Our next question says, an electric dipole when held at 30 degrees. So let's write the given data, given information, 30 degree here, with respect to a uniform electric field. So electric field value here is 10 to the power 4 Newton per coulomb, uniform electric field. Experiences a torque. Torque, let me write it as 9 into 10 to the power 26 minus 26 Newton meter. Calculate the dipole moment. So direct formula based thing here it is. So this will be torque tau equals to PE sine theta. PE sine theta. What they are asking? Sir, they are asking dipole moment. So P will be equals to torque tau whole divided by E sine theta. And what is torque? 9 into 10 to the power minus 26. Electric field 10 to the power 4 sine theta half. Let's take this 2 on the top. So it will be 2 nines are 18 into 10 to the power 4 goes up. So it will be negative and minus 30. What's the unit of this dipole moment? Coulomb meter. Another unit I want to introduce, that is dBi. So even if you find somewhere written dBi or coulomb meter, both are correct. Let's move to the next one. Next question says, S1 and S2 are two concentric spheres enclosing the charge Q and 2Q respectively as shown in the figure. So S1 encloses the charge Q, and so there is all over this place charge Q, and all over this place charge 2Q. Okay, S1 and S2. What is the ratio of flux through S1 and S2? Let me remind you, from Gauss's law, flux phi is equals to charge Q upon epsilon naught. This is our Gauss's law. So we will apply here Gauss's law only, okay, to figure out the flux. So first of all, okay, phi S1, flux due to the surface S1, what it will be? Sir, Q upon epsilon naught, because the charge enclosed by S1 is Q. And what about phi S2? Be very careful, majority of people go wrong here. The charge enclosed by surface S2 will be Q plus 2Q. Both the charges are inside that upon epsilon naught. Where the students do mistake, they simply write 2Q upon epsilon naught. So S2 in the Gauss's law, that's why I usually write total charge inside the Gaussian surface. So here it will be Q plus 2Q upon epsilon naught. That is nothing but 3Q upon epsilon naught. Now they are saying find the ratio of both the flux. So phi S1 upon phi S2, that will give you Q by epsilon naught upon 3Q by epsilon naught. Let's cancel out epsilon naught, and we left with 1 by 3, or we can write it as 1:3. This is the ratio. This is done. Let's move to our next problem. Question says, consider a uniform electric field E, which is equals to, let me rewrite this expression. E is electric field vector, which is 3 into 10 to the power 3 I cap. I cap means the electric field is along x-axis, 3 into 10 raised to 3, correct? Calculate the flux of this field through a square surface of area this much, when the plane is parallel to YZ plane, and the normal to its plane makes 60° with the x-axis. Okay, we'll come back to this question. For a minute, what I am doing is I am resharing the screen. I'll explain the concept and I'll come back to this so that we can understand this problem better. So I hope you have seen this screen before also when I explained 3D concept. Okay, so let's recall our concept of flux. Let me remove this and I'll add here a new object, a plane. Okay, I'll take this object and I will simply rotate it. Okay, along let's rotate it along one particular axis, and let's rotate it along this axis, let's say. Okay, so this is our plane. This is our plane. Be very careful with this. If this is the plane, sir, where is the normal to this plane? Sir, normal to this plane will be simply along this direction. Let me just draw it. Normal to this plane will be perpendicular to this, right? This is called normal. Normal means 90°. Okay. If you want to see the front view, you can see the front view also. These arrows which I made, they were perfectly 90°. And not only in the front direction, they are also in the back direction also perfectly 90. So I am just making here N. This is normal. Now, if an electric field is along this direction only, making, listen very carefully, if this is electric field and this electric field is making 90° with the plane, 90° with the surface, this is our surface. So if this is making 90° with the surface, then what is the angle between the normal and electric field? Look from 3D. What is the angle between the normal and the electric field? Sir, both are pointing in the same direction. They are parallel. So theta is 0°. Clear? So this is our E1. I am assuming this is electric field E1. Now let's take another electric field in this direction. Or let me just put it from the top. This is our E2. Now E2 is along the surface, along the plane. So what is the angle between E2 and the normal? So now it is 90°. Clear it is? Let's take a recap of this, what I have just now explained. So if you have a surface, the angle is always, in the flux formula, the angle is always taken between normal to the surface and electric field, not between electric field and surface. In the first case, electric field is making 90° to the surface, while it is making 0° with the normal. So we will take 0°. In the second case, electric field is making 0° with the surface, but it is making 90° with the normal. So we will take 90. We always take electric field and normal, always. Not between field and the surface, between field and the normal. Why we do that? Because, sir, if someone is firing bullets from here, the best way to keep this shield like this, then only we can stop it. If someone is firing the bullet in this and you keep it parallel, okay, it will pierce the body. Clear it is? So I hope this concept is clear. Let's keep in mind this thing and we will understand our next question. Let's continue. Question says, consider a uniform electric field E. This is along x-axis. Calculate the flux of the field through a square surface. So this is a square surface I am drawing here. Okay. And this square surface is parallel to whom? YZ plane. If it is parallel to YZ, what is the perpendicular? So imagine inside your room, YZ plane. How can you imagine that? Imagine any corner. Look around. Look at the corner of your room. Take it as x-axis. Take it as y-axis. Do this right now and take it as z-axis. Clear? Okay. Look at the corner. Decide one axis as x-axis, one axis as y-axis, and one axis as z-axis. Then this wall will be yz-axis. YZ plane we will call it. Bio people, focus. This is YZ plane. And if it is YZ, which axis is perpendicular to YZ? X-axis. Correct? So here, if this is a plane parallel to YZ plane, then what is the normal? The normal of this plane is pointing in x-axis direction. Clear it is? And if it is normal is pointing along x-axis, okay. And what is the area? Sir, area here will be, we will have to find, because oh, area is already given. Area of this is 10 centimeter square. So centimeter square we will convert here. Let's write here a equal to 10 into 10 to the power minus 4 meter square. Centimeter square converted into meter square, correct? Now I'll not teach that in 12th standard. 10 to the power, how it got minus 4. That's our. So let's recall our second formula. Sir, question is, I have one more question, sir. Every time when we get question, how do you decide that when to use Gauss's law and when to use this electric field? Phi equals to EA cos theta. Be very careful when electric field and area is given. This is obvious that this is to be used. But sometimes to confuse you, they can also give electric field also and charge also. Always remember, we use Gauss's law when the charge is given. Total charge enclosed upon epsilon naught, that is always first priority. If electric field and area is given, then we will use. But if both are given, priority is given to charge. Clear? So E into A into cos of theta. Now what is electric field? Sir, electric field is 3 into 10 to the power 3. Area, what is the area? So 10 into 10 to the power minus 4. And what's the angle between the normal and the electric field? Sir, electric field is also along x-axis. Pay attention, I cap. It is along x-axis, and area normal vector is along x-axis. So theta is 0 degree. Recall our that animation part just now I explained there. So theta is 0 degree because the electric field and the normal to the area both are pointing in the same direction. Normal to the area. Listen very carefully. So this will give you 3 into 10, 30 into 10 to the power minus 1, which is 3. What is the unit? Electric field is Newton per coulomb and meter square. Done. Newton meter square per coulomb. This is the flux. First one. This is our first part. Second part. The normal of its plane makes 60 degree with the x-axis. Great. So if this is 60 degree, this is our plane. Okay, now see how the diagram will change for the second case. And what angle you will have to take, 60 or 30. Majority of people are confused in that. Should I take 60? Should I take 30? We will try to think about it. So if this is our x-axis and the plane is making 60 degree. So let's make a plane. Okay, roughly drawing this plane somewhat like this. Okay, so if it is how much? 60 degree with the x-axis. Be very careful. The normal of the plane is making 60 degree, not the plane. So I did a mistake here. I didn't draw the diagram properly. Okay, so let's first draw a normal here. Okay, any plane over here. This is our normal, let's say. And let's say this is our x-axis. Then what is the angle between normal and the x-axis? 60 degree. The angle between normal and the x-axis is 60 degree. And in which direction the electric field is? Sir, read the question again. Read the question again. It is again at I only. Question is not changing. Electric field is not changing. Electric field is still along x-axis. So this is our electric field direction. Correct? So normal and electric field. What's the angle between the electric field and the normal? 60 degree only. Be very careful. Let me repeat again. Normal and the x-axis. They are both having 60 degree. And x-axis is the direction in which electric field exists. So angle between normal and the electric field is also 60 degree here. So here you will take 60 only. So read the question very carefully. Okay. So what will be the flux now? Flux will be electric field, which is 3 into 10 to the power 3, area, which is same 10 to the power minus 4, and into cos of 60 degree. Clear it is? Okay. So this will be, so this will be 3 into 10, 30 into 10 to the power minus 1, and cos 60 is half. So it will be 15 into 10 to the power minus 1, or 1.5. What's the unit? Newton meter square per coulomb. Be very careful with the angles. So keep in mind that video, okay, that part of video that where I explained you the animation, very, very important. Angle is always taken between the field and the normal. Let me repeat, field and the normal. Let's move to our next question. The next question says a spherical Gaussian surface encloses a charge. Here straight away charge is given. So charge is 8.85 into 10 to the power minus 8 coulomb. Calculate the flux passing through the surface. Direct question, Gauss's law, flux phi is Q by epsilon naught. Q is 8.85 into 10 to the power minus 8. Epsilon naught, 8.85 into 10 to the power minus 12. You have to remember this, otherwise it will be on the first page of the board exams. But for competitive exams, you have to remember this. So 8.85 cancels out, 10 to the power minus 12 goes up and becomes plus, and it will be 10 to the power 4. What's the unit? Newton meter square per coulomb. That's our first part. Second part says if the radius of the Gaussian surface is doubled, how would the flux change? Most common question, repeatedly asked many times in board exams. If the radius of Gaussian surface is doubled, how would the flux change? If you look at the Gauss's law over here, is there any parameter related to the radius? No, sir. So it won't change. So flux phi is independent of a radius. So it won't change. Some students, they starts thinking about E dot area and they write what? Okay, let me repeat. What students do here is they think about this formula E dot area. Area is what? Sir, 4 pi r square. If r gets doubled, they write it as 2 2s are 4 and it becomes 4 times. Wait, if r gets doubled, even electric field also decreases, right? Because E is also kq by r square. So if this is increasing and this is decreasing, okay, the overall value will remain same. So be very careful if you are using this formula also to evaluate. The best one is don't get confused, just focus on Gauss's law. So this is our answer to the second one.
Watch the complete playlist on the app Pions. Download the app now.